Okay, so in this video I'm going to be handling the first 9 questions in the differential calculus assignment. Also, I noticed the last video the blue pen was pretty hard to read after watching it back, so I'm switching to green, so hopefully look a bit better. Anyway, with that out of the way, I'll just get on with question 1. So this is how it goes. Evaluate as x approaches 5, x squared, take away x, take away 20, divided by x minus 5. And, I mean, you can immediately see the problem here. The problem is if x equals 5, you'll be dividing by 0, which it breaks maths. So, what we have to do first is factorize the top, and we'll get this. And to factorize this, it's a pretty easy one because we know it has to have the x minus 5 to cancel with it. So it'll be x plus 4, x minus 5, on x minus 5. We can see these two cancel out. We're left with x plus 4, and as we know, x is approaching 5, so it'll be 9. So that's the answer to question 1. It's just 9. Alright, so let's go on to question 2. Okay, so pretty much we've got y equals 2x cubed plus 3x squared minus 18x plus 8. And we have to find the average rate of change between 2 points, 2 x values. And those x values are and x equals 2. So I find it easy to graph this question because we've got to be able to visualize it. So here I'll draw a little thing here. So let's first evaluate this function at 0. As we can see, if we make all the x's 0, these all just cancel out, so it'll be just equal to 8. And if we put in 2, it'll be equal to 2 cubed, which is 8 times 2, 16, plus 3 times 4, so plus 12, minus 36, plus 8. And we can see here that this is actually equal to 0. So what this all means is that when x equals, actually we can just put the coordinates down. So x equals 0, y equals 8. So that'll look something like that. And when x equals 2, y equals 0. So then what we can do with this information is draw a little bit of a triangle, and that triangle would be placed here. And this length is 8, this length is 2. We use the rise over run formula, and we get 8 over 2 equals 4. But as we can see, it is going down, so it's minus 8 on 2. Actually, I'll make a bit more space here. Therefore, average rate of change equals minus 4. And that's the answer there. So 2 down so far. Oh, that was 2a. Alright, now we've got 2b. Oh, am I going to need that? No, I'm not. Okay, 2b, we can do that. Okay, so 2b is quite similar. It's just saying what is the oh, you can't see that at x equals 0. So again, we've got 2x cubed plus 3x squared minus 18x plus 8. So when you see the word instantaneous, that means you have to take the derivative. And I explained how to do this in the last video, so we're going to be using the really simple method, not that long expansion. And we're just going to realize that the derivative is 6x squared plus 6x minus 18. And then what we do now is sub 0 into the derivative, because it says x equals 0. And if we make x equals 0 in all of this, it's just equal to minus 18. Therefore, instantaneous at is minus 18. And that is the answer for 2b. Alright, so far so good, I think. Let's get on to the next question, which is question 3. So, this one has 4 parts, so we'll start with A. So it's asking us to differentiate minus 5x squared plus 18 minus 3 on x. So you'll see the problem here that we've got the x on the bottom here. So what we actually have to do is bring that up to the top by rewriting it as this. To the power of minus 1 by using our index law to move this up here. And then we can pretty easily take the derivative of this, and that's f of x. 2 times minus 5 minus 10x. And here, this might look a little bit confusing, but it's actually quite easy to take the derivative of this. You just multiply the minus 1 by the minus 3 to get plus 3, and you again subtract 1 off this, so minus 2. And we're not going to leave this in negative indice form. We're going to put this to the bottom. So it's 3x to the power of minus 2. So I forgot that part. And then, therefore, the derivative equals minus 10x plus 3 on x squared, because we'll move that x to the bottom. Okay, so next up, 3b. And they're asking us to differentiate y equals 6 root x. Okay, so here's how we're going to rewrite this to make us able to differentiate it with the root. So we're going to say f, so derivative equals 6x to the power of 1 over 2, because that's equal to the square root, which we can then put down and differentiate it. So 1 on 2 times that, so 3 x to the power of minus 3 on 2. So then what we're gonna do is what have I made a mistake here? Huh. I'm just gonna check this against the calculator for a second. Menu calculus. Alright. So, sorry about that. So here's what we do once we're at this point. We're gonna say f, so derivative equals 3. Oh, I see what I did wrong. I thought that was a minus a half. Okay, so never mind. We're gonna do 3x to the power of minus a half, and then we're gonna do 3 divided by x to the power of 1 over 2. And this is the answer actually, but we turn it into equals 3 on root x. And that's the answer. Sorry about that. It's a bit careless. Alright, now let's go on with C. So we've got 4x squared plus 8x minus 5 all on x squared. Alright, so I think the first thing we're going to want to do is separate it all out, because we can see it's all pretty messy up here. So we're going to want to make it 4x squared on x squared plus 8x on x squared minus 5 on x squared. So now what we're going to want to do is we'll cancel these out, these x squares out, and we'll get 4 plus, we're going to want to move this up to there, 8x to the power of minus 1. We're going to want to move both of these up here, minus 5x to the power of minus 2. From here we can differentiate this. So, derivative equals, so we'll go the minus 1 times that, minus 8x to the power of minus 2, plus, because minus times minus, so plus 10x to the power of minus 3. And then of course we'll move these down to the other side. Minus 8, wait no, sorry, minus 8 on x squared plus 10 on x cubed. Alright, so now we've got this, but we can clean it up a little bit more. So to make these denominators the same, we're going to make them both x cubed. And we're going to make it 8x on x cubed plus 10 on x cubed. From there we can combine it into one thing. And if you want, you can pull out a common factor of minus 2. And it'll look like this. So 4x plus minus 5 on x cubed. There you go, that's the derivative of that. Okay. So let me just erase all that. In question 4D. Sorry, 3D. Okay, this one looks a little bit easier. Alright, so we've got 3x minus 5 squared. Alright, so the first thing we're going to want to do is, of course, expand these brackets. Sorry, I can't really see that top. Okay, so we've got 3 squared is 9x squared. And to expand a cube, you do 2 times a times b. So 3 times minus 5, that's minus 15x. And then times that by 2, so minus 30x. And then the minus 5 times minus 5 is plus 25. Therefore, derivative is 2 times 9, 18x, and 1 times minus 30, minus 30. There you go, that was a bit of a shorter one. Alright, let's get right on to question 4. Hope all is clear so far. Alright, so I'll make that easier to see. 4. Alright, so here's what we're gonna do to start solving this. So the first thing we have to do is actually be able to work out what the tangent is. And to do that, we have to take the derivative. And to take the derivative of this, you'll see the x on the bottom, so we have to move it up to the top. So I'll say y equals 3x to the power of minus 2. Sorry, minus 2. And then from there, we'll take the derivative. Minus 2 times 3 minus 6x to the power of minus 3. Okay. And then we'll put this on the bottom. Alright, so we've got the derivative now. And we will now find the gradient of the line at x equals 2. So we'll do derivative evaluated at 2. So that just means we substitute x for 2. And we'll get minus 6 on 2 cubed, which is 2 times 2 is 4 times 2 is 8. 6 on 8. Six on 8 simplifies down to 3 on 4. And now we've got this. So now, what we know is that when x equals 2, y equals 3 on 4. Okay, so then we substitute this in for the y. So we say y equals minus 3 on 4 times the x point plus c. So this is just y equals mx plus c form to solve this equation. And to if we do this, we get 3 on 4 equals. Okay, so minus 3 on 4 times 2. So times 2 on 1. So we'll get minus 6 on 4. So, kind of running out of space here. Okay, I'll bring this back up here to the top. Okay. So, we've got this plus c. So we've got 3 on 4 equals minus 6 on 4 plus c. And if we put this onto the other side, we get 9 on 4 equals c. Therefore, the equation of the tangent is y equals, and the gradient is minus 3 on 4, x plus c, which is 9 on 4. And sorry, that's a little bit messy, given the layout. So sorry about that, but that's the final answer there. Okay. So next question. We've got 5. And I think this one is pretty easy. Pretty much. We've got the, okay, this is going to take me a second to write out though. Alright, so pretty much what we have to do is sketch a graph based on all of this information. And it's actually pretty easy, we just have to go through each part. So, I'll draw this. The first bit of information that I think it's easiest to use is f0 equals minus 4. So what that means is when this function is evaluated at x equals 0, the y value is minus 4. Which means if we put x being equal to 0, y is minus 4, we've got our y-intercept. And the next bit of information is this up here, which gives us our x-intercept. So it means when this function is evaluated at minus 3 and a minus 2, the y value is 0, which means if we put a point at minus 3 and 2, we've already got our x and y intercepts. So we can really start from any other point, but I think we'll do 3 and 4 next. So the derivative is less than 0. So what this means is that between these 2 points, the line is going down. So if we put a little point going down here, ending at -1, it's going down. And for this 4, when the derivative is greater than 0, that means the line's going up. When -3 is greater than x, so up there. And when x is greater than -1, which is up here. And this is further backed up by number 2, which says that, I mean, it's kind of irrelevant information because we already know it, but pretty much when x is -3 and x is -1, the derivative is 0, which means it's flat. So if we've got a curve, that's when the derivative is 0, and those are at the turning points. So there you go. I'll draw a bit of a neater one actually, because that all looks a bit messy. Just make a bit more space. Alright, so this is what the final graph looks like. Wow. We've got -3, 2, -4, and down here, x equals 1. So, we'll start from here, turns at -1, comes back up, touches that, and goes back down. So there you go. That is the answer to question 5. Okay, so question 6. Alright, this is a bit of a harder one. So, find on the curve y equals -1 on x. That's gone off. -1 on x. Alright, so this is a bit of a long one. So where do we start? So the first thing I think we should do is get this 9y on itself, so we can just have this in a simple gradient form. So we'll start by moving this x onto the other side. So we've got that. Then we just divide both sides by -9, and we'll get y equals, these two minuses cancel each other out. We have the 1 on 9x minus 5 on 9. So we've got that now, and the next thing we want to do is get the derivative of this part, and we'll first do that by moving this x up here. So we'll rewrite it as y equals -1 x to the power of -1. From there we take the derivative. 1 minus 1 times -1 is just x to the power of -2. And then because the power rule, you go down there. Alright, so if the point is, if they're parallel, their gradients are the same. So that means that equals 1 on 9. And as we can see, the derivative is equal to 1 on x squared. So it's pretty simple to work this one out. What value x has to take on to be equal to 9, and that's just minus 3 or 3. So x equals plus or minus 3. So here's what we do next. So pretty much what this is telling us, that if we were to draw both of these lines at x equals plus or minus 3, they would be parallel to each other. But what they're actually asking is for the coordinates to the point, which means we also have to find out the y position. So we sub it back into y equals 1 on x squared. Wait, no, we won't. That's the derivative. So we'll sub it back into minus 1 on x. So we'll start with 3. Y equals minus 1 on 3. Therefore, coordinates are 3, comma, minus 1 on 3. And we'll make x equals to x equal minus 3 now, which will make it minus 1 on minus 3, which is just equal to 1 on 3. Minus 3, comma, 1 on 3. And that is the final answer there to question 6. It's a bit of a longer one, but I hope everyone can understand what we did there. So it was pretty much just a case of finding the gradient of this one. Actually, I'll use a different color to make it clear. So we first had to identify what the gradient of this was, and then take the derivative of this to get this equation. This is a key part, making them equal to each other. And then once you solve this little equation here, you'll get both x values. Then you just sub that back into the original equation, and it'll give you the y values. And there you go. Okay, so that's a tangent question. Okay, so question 7. Okay, alright, this is a 3-part question. Oh, wait, let me just switch back to green, because I quite like green. Okay, so 7. Using calculus techniques, find the... That was a bad E. Coordinates of y equals 2x cubed plus 9x squared, take away 24x plus 2. Alright, so to do this, we first have to take the derivative. You'll notice we do a lot of the derivative, and my teacher said that if you're in a calculus test, it's a pretty safe bet to just take the derivative, and you'll get some points, at least if you're doing differential calculus. And pretty much what this stationary points means is that if we draw a random curve, the stationary point is when, that's not very good, it's touching there, and the gradient is equal to 0. So what that means is that that equals 0. So first we'll actually have to take the derivative. And 3 times 2, 6x squared, 9 times 2 plus 18x, 1 times minus 24, minus 24. Alright, so now we've got that, and equals 0, because the whole point of it is to be 0. So, what I'm going to do is, we can see they're all divisible by 6, which means we can just get rid of it all. So x squared plus 3x minus 4 equals 0. Now this factorizes quite nicely. X plus 4, x minus 1. Using null factor theorem, x plus 4 equals 0. So x equals minus 4 and x minus 1 equals 0, so x equals 1. So these are the two x points. And what we have to do next is actually work, because again they ask for the coordinates, which means we also have to find the y values. So what we'll first do is, I think it's easy to just do it at 1, so f1, and this just means for each point for each x in this expression, we just change it to 1. So pretty much we can ignore all this. So 2 plus 9, take 24 plus 2, and that should all equal minus 11, and f minus 4. Alright, so this one's a slight bit more complicated, because we have to actually do some stuff. So minus 4 cubed, that's minus 64 times 2, so minus 128. Minus 4 squared is just 16. 16 times 9 is 144, plus 144. The next step is handling this. Minus 24 times minus 4 is plus 24, plus 24, and then plus 2. So I'm just going to plug this into a calculator because I don't really want to work that out. Minus 128 plus 144, 298. Oh wow. This is quite embarrassing. I forgot to actually multiply minus 24 by minus 4. My apologies. So if we change this to plus 96 plus 2. Wow, this is not going too well. Minus 128 plus. You know what? Minus 128. And that is equal to 114. Alright, thanks for bearing with me. 114. Therefore, stationary. Oh, jeez. 1 comma minus 11 and minus 4 114. Alright, there you go. That's the answer. Okay. Alright, so that was just A, by the way. We've got to do B next. Alright, so to do B, we have to state the nature. So what this means is that if we've got this here, this stationary point is a maximum. But if we've got this, then this stationary point is a minimum. And we also work this out using calculus. Okay. Alright, state the nature of the stationary points. So I'm going to be using the second derivative. And I'm just going to have to quickly get the derivative again. So f equals 6x squared plus 18x minus 24. So here's the second derivative method of finding the nature. So we take the derivative of the derivative, and we get 2 times 6, 12x plus 18. Alright, so we then sub in both of our x values, f dash dash 1, and we'll get 12 plus 18. We can see that's pretty clearly positive. So that's greater than 0, which means, this is how I remember it. We're happy. That's the shape of the graph. And we'll do f double dash minus 4. So you don't actually have to work this out because it's pretty obvious it's going to be negative, which means it'll be sad. So what this means is that this is going to be the final answer. Therefore, local minimum here, so that's a minimum because we can see it doesn't go lower, at, and this is 1 comma minus 11 plus local, we can see here this is a local maximum here, at minus 4, oh I didn't put these in brackets, minus 4 comma 114. Alright, there you go. That's it. That's 7b. Now, section C is pretty straightforward because we already know all this information. In fact, I'll leave this information just because it's kind of useful. It's pretty much just asking us to sketch the graph. So, we'll draw a nice, I don't know what's wrong with me, can't draw these. We'll sketch a graph. So the original equation is this. So what all of this means is that when x is 0, all these cancel out, which just leaves the 2, which means the y-intercept is 2. We've got our local minimum, at 1, so 1 across and minus 11 down. So 1 comma minus. And we've got the local maximum at minus 4 across and up 114. And this is not to scale in any way. Pretty much we can draw this. I'll just extend that a bit. So look a little something like Jesus. Alright, it's a very messy looking graph, but you get the idea that I haven't made this that obvious, but the maximum is here. This here is the maximum. Okay, so that's question 7 done. Let's get on to question 8. Alright, we're almost at the end. 2 more questions to go. Whoops. Switch back to green. Okay, so first principles, I actually made a whole video on this. So I'm just going to go through this pretty quickly. So we've got fx plus h minus fx all on h. So we'll start with writing this, which means we'll put this in brackets, 5 minus 5 minus 3x squared all on h. So I just missed a bracket up there. So we'll expand this out. 5, so minus 3x squared. So 2 times that, which will leave minus 6xh minus 3h squared minus 5 plus 3x squared on h. I'll again switch to red just to show. Cancel, 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 cancel. And we're left with, oh my god, I keep forgetting. Minus 6xh minus 3h squared all on h. Alright, what am I gonna do? Alright, we'll make some more room up here so we can continue working. And again, what we can see here is that these all have an h in them, which means we can take out a common factor of h. H minus 6x minus 3h on h. Let's quickly erase that. What we can then do is cancel these h's and write and of course as h approaches 0 we cross this out. Minus 6x, and that's the final answer. And we can check it by getting the original one back. 5 minus 3x squared. You bring this down here, and minus 1. This is irrelevant because it doesn't have an x in it. Minus 6x. And there you go. Alright, that's question 8 done. Oh, we're only one away. Question 9. This is a pretty tough one though, so. So it's a 3-part question. So, 9a. Alright, let's just write the information. So, x equals minus 1 on 2 t minus 4 squared plus 8. So, x is this. You can't really see that. Alright, never mind. Alright, t is time. So, a. They're asking what's the average velocity. So pretty much what we have to do over the first 6 seconds. So what we have to do is first find out what it is at the start. And this t is equal to 0 because seconds is at 0, which means 16 plus 8, which, I mean, it's pretty convenient, but minus a half times 16 is minus 8 plus 8, which of course equals 0, and function evaluated at 6, because that's the second point. So if you read this question, it says what's the average velocity over the first 6 seconds. So we're finding this first one, and then we'll find the second one. So we've got minus 1 on 2, 6 take away 4, 2 squared plus 8. So minus 1 on 2 times 4 is minus 2. Minus 2 plus 8 equals 6. Oh, that's pretty convenient. So, therefore, so we've got the time of 6 seconds because it's the first 6 seconds, and we've got a difference of 6 meters. Well, if we see in meters, because I do actually mention that it's in meters. So we've got 6 meters across. So if we look at time, so that's 6. This is distance, which is 6. We do rise over run, 6 divided by 6 equals 1. So this is going to be the final answer. Therefore, average velocity equals 1 meter per second. Alright, there you go. That is question 9a completed. Alright. So let's get started with 9b. So this is average speed of the first 6 seconds. Alright, so this is actually a little more complicated, and And I'll show you why. It's because it's not just purely based on where the particle ends up, it actually matters what path it takes to get there. For example, so it's pretty easy if we just sketch this graph. I think that's the best way to do it. It doesn't really matter how you sketch it. It's just important that you do. And we have 0 and 8. And we have a curve coming up here. Oh, that's pretty badly drawn. Got a curve like that. That's also pretty bad, but it doesn't really matter. So we've got a turning point of 4, which means 6. So this is seconds moving along here. The point is between this point and this point. So this is going to be 6, 6, because we already know that when x is 6, y is also 6. But the problem here is it doesn't just matter displacement. Displacement is distance. So if we look at this graph, we'll make it a bit bigger. Displacement is simply distance from here to here. It's like what this length is. But distance includes this whole thing, like along here, which means this part. So, how do we get started doing this? I'll leave this here because it makes it easier to understand, I think. So the first thing we're going to want to do is, because we know that the turning point is 4, because it's just a parabola with these two x-intercepts, which means if we evaluate, if we evaluate it at 4, it'll give us this other point, which means minus 1 on 2. Oh, 4 minus 4, so that's just 0. That just cancels out. So it's just 8. So this is some important information. And here, and then this next part is pretty easy, because we already know that the function evaluated at 6 is equal to 6, because we did that in the last question. Which means that this distance, I'll switch to red, this distance here is 8 minus 6, which is 2. So that distance is 2. We'll just make that really clear. So that distance is 2. Therefore, total distance is 2 plus 8. And the 8 is to here originally. So which means the total distance is from this point to this point. That's the first part. Well, it's really the second part here. That's the 8. And then the next part is from the 4, 8 to 6, 6. So the total distance is that. And it's over 6 seconds. Therefore, average speed equals, well, that equals 10. So the total distance is 10 meters, and the time is 6 seconds. So 10 divided by 6. So speed equals distance divided by time equals 513 meters per second. Alright, that's the answer to this question. Yeah, good fun. So C is So the moment you see instantaneous, you know, jeez, I don't even know what I've done up there. Instant. So this means that we're going to have to take the derivative at some point. So, to take the derivative of minus 1 on 2 t minus 4 squared plus 8, we're going to rewrite it as this. Minus 1 on 2. We're going to do a little expansion. So we're going to expand these brackets in here to get t squared, and minus 4 times t is minus 4t, and then times 2, minus 8t, and then that squared plus 16. So we've got this, and let's just keep on going. We don't really have to worry about this because we know it's not going to make any difference when it comes to calculating the derivative. So let's just expand this out and we'll get 1 minus 1 on 2 t squared, and minus 1 on 2 times minus 8, that gives us plus 4t, and minus 1 on 2 times 16, it gives us we've got a bit of a problem because this t looks exactly like a plus sign. So plus, wait no, it'll be minus 8. Sorry, my apologies. Minus 8. And then once we've done this, we can take the derivative of that by doing 2 times minus a half, which just gives minus t, and that plus 4. Okay, so minus t plus 4. Sorry, this t makes it really weird to work with, but this here is a t, which means derivative evaluated at 5 seconds, because we're trying to work it out at 5 seconds, is equal to minus t, so minus 5 plus 4, which means equals minus 1. Therefore, instantaneous velocity at 5 seconds is minus 1 meter per second. Okay. Alright, all 9 questions done. Hopefully I'm going to make a part 2 to handle the last, I believe there are 13 questions on this assignment. Yeah, 13 questions. Alright, so thank you all for watching. I hope you did learn something and you can apply this to questions of similar nature. So yeah, thank you all for watching. See you.